First of all, we'll dive into textual neurons algebraic specification, where its operation gives us as a result either a modification into the textual neurons connections or the result of the calculation of the output. As well, on our neural network ADT, we define all the operations that could be done into a network, defining the parameters that are going to be needed to execute them. In this case, the operations are related to the creation or modification of a neural network and the visualization of it as a whole, or some other values like input and output values, for example. We can appreciate that this structure uses linear structures. For example, connection forward and connection backward in textual neurons are array lists, indicating linear storage of connections. In addition, the list of neurons in the neural network could be considered linear. By the way, we are clearly talking about non-linear structures. Since we have interconnected nodes, that neural networks involve connections between nodes, creating a network structure that is inherently nonlinear. By the way, we have also a layer architecture, as the presence of layers, in this case input, internal and output, contributes to the non-linear organization of neural networks. And the final reason is the graph-like structure. Neural networks can be conceptualized as direct graph where neurons are nodes and connections are edges, reinforcing their non-linear nature. As we've talked before, our data structures make use of array lists. This means that they handle dynamic memory allocation. The manipulation of inputs, connections, and other properties of neurons and the neural network is dynamic, indicating an approach that adapts to change at runtime. We must highlight too the adaptability to size changes. Dynamic memory allocation is essential to adapt to changes in the size of the neural network, input, or any other feature that may vary during execution.
Now we go ahead with the class implementation. The first class is the textual neuron, which has 5 attributes: the ID, the neuron type, the input, and the connection forward and backward. Then the constructor of the class, also the neuron type enumeration. Following, we have 3 methods: the sum, the reduction, the fusion methods, which are going to perform the operations depending on the neuron type. Then the evaluate method, which executes the corresponding operation for each neuron type and returns the result. Consequently, we have 3 methods: assign input, add input, and reset neuron input, that will allow us to manipulate the neuron inputs. Also, we are going to use the add connection forward and add connection backward methods for connecting the neurons in the network. This is the neural network class, which has 4 attributes, which are 4 lists that are going to store the neurons in a modular way. This class will be able to create a neuron as well as adding input, output, and internal neurons to their corresponding lists. We will also have the ability to assign a value to an input neuron. We will be able to change or to add any value of an input neuron, as well as connecting the neurons with these 2 methods. Then we are going to find the methods to show the information to the user. The method display outputs, evaluate net, which will work with evaluate net recursive, which will be a method that calls itself recursively. And finally, we have the visualize network method, which will show us all the connection and the structure of the network. Moreover, we have the method visualize inputs, which will allow us to see the input of every neuron in the network. Now we are going to show the program execution. Firstly, we are going to create the network with this method, which will ask to the user for the inputs, and will create the network using the methods on the neural network class. Then we are going to execute these methods to show to the user the network state. First of all is introducing the inputs. We can introduce any string that the neurons will process and do their operations. This is the output of the network. Then the network display, we can see the input neurons information, the intermediate neurons, and also the output neurons information. Following, we have the input of each neuron in the network, and then the result of the recursive method evaluate network.